Hello folks, as I told you that we'll be meeting with the next problem where the application is changing a bit. So we are going to take we're just going to go through the question. What does the question say? Question says that show off, that's a 19th question, show that of all the rectangles inscribed in a given fixed circle, the square has the maximum area. So this is our 19th problem. They say that there is a rectangle which is there inside this particular square, this particular circle. The circle has a fixed radius. There is a certain radius. Radius is not going to change. This much is the condition that's given to you. If you have a fixed circle, then inside this fixed circle, you are going to place a rectangle. You have to find the area, the dimensions of that square, which is going to make the area maximum. Well, that's the kind of thing that we have to do. So to begin with, even before we could assume things, let's have some fixed radius r or something like that. So there is this fixed circle in which there is a rectangle which is inscribed. Yes. So this is what is going to happen here. You have a circle and there you have a rectangle inside that circle. That's it. Yeah, as we said, no, let's have the radius as some r or something that doesn't change. Suppose, say, if you have this rectangle whose length is x, and the width is y, and the radius as we assumed, let it be say capital R or something like that, something that doesn't change, not a variable one. This is the scenario where we have got the circle. As we say that let's have the radius as r for this. So this is the length, this is the width. So all these assumptions, let's write it down and let's get across doing the work. Let x comma y be the length and width of the rectangle of the required rectangle, and r be the fixed radius. Yes, and maybe this is the center O. Okay, fixed radius of the circle with center O. Yeah, so this is the scenario. Now, as we know, you have read through the question. Question says that the area is maximum. So area is length times width. If we were to put length times width, then it's going to be x times y, two variables. That's again a place where we get where we are not so comfortable. So therefore, we have to get this translated in terms of one variable. So that's going to be our work first. Let's look at this right triangle. For our convenience, let's call it as ABCD, this quadrilateral ABCD. So we can just observe in right triangle ADC, we are able to see that x squared, it's a Pythagoras theorem because it's a right triangle, x squared plus y squared is r plus r, which is 2r. So it is 2r the whole squared. Why we get this? We get this by Pythagoras theorem. Okay, so what happens? X squared plus y squared makes it 4r squared. We can make y squared substituted as 4r squared minus x squared, but that's y squared. We know that we require y. So therefore y is going to be root of 4r squared minus x squared, call it as 1. We'll use it whenever required. And then quickly go on to the area. We know that in the question they have said maximum area. So let's go on for the area. Therefore, area of quadrilateral ABCD, that's going to be length times breadth. We all know that area for a rectangle is length times breadth. That means it's x times y. And we know that since we are not okay with the two variables, so we are going to substitute that x from equation 1. It is going to become 4r squared minus root of 4r squared minus x squared. That's it. So we have got now the area in terms of one variable x, but that's not all, because we know we should get the first derivative, we should get the second derivative, and then so on, get the critical point, and hence get the value. So much task is left. So let's right away go for the first derivative. Let's get the first derivative here, dA over dx. So for the first derivative, let's treat it as a product and do it. Maybe this is u and this is v. So x as it is, derivative of the root, we all know is 1 over 2 the times the function, 2 with the root sign. So that's the derivative of the exponent, that is raised to half. Now derivative of the base. So derivative of the base, 4r squared is fixed, so there's no derivative. Minus x squared has got the derivative minus 2x. That's the first part. Now for the second part, keep root of 4r squared minus x squared as it is and take the derivative of x, which is 1. Therefore this is minus 2x squared. We can have the 2 cut. Minus x squared over root of 4r squared minus x squared plus root of 4r squared minus x squared. You can get it equalized so that the working is simpler. Times 4r squared root of 4r squared times, so that you can have it equalized. So you have minus x squared plus, see, root a into root a is a, we know. So this is going to be 4r squared minus x squared by, as I told you, root and root, it's going to be just root a into root a is a. So it's going to be only 4r squared minus x squared. In the denominator, again, we have equalized it. It's 4r squared, root of 4r squared minus x squared. When we solve this, it's going to be 4r squared minus 2x squared over root of 4r squared minus x squared. So that's the first derivative. We cannot stop there, so we have to go for the second derivative. In the second derivative, obviously we have to look at it as a quotient and we have to work with the quotient. So first we will keep root of 4r squared minus x squared as it is and get the derivative of 4r squared minus 2x squared. 4r squared doesn't have the derivative. Derivative of minus 2x squared is minus 4x. So also minus 4r squared minus 2x squared as it is, and the derivative of root of 4r squared minus x squared, we have seen just now that it is 1 over root of 2 times root of 4r squared minus x squared, and derivative of minus x squared is minus 2x, out of which these can cancel each other, and by the formula we have this root of 4r squared minus x squared the whole squared, which will come to 4r squared minus x squared. Little bit of solving you can do here. So it will come to minus 4x times 4r squared minus x squared, first bracket. Second bracket, it's going to be minus and minus plus, so x times 4r squared minus 2x squared, and in the denominator you have 4r squared minus x squared and root of 4r squared minus x squared when we equalize it. So that's our second derivative, and that is only to check the maximum part. Now in order to get the critical point, let dA over dx be equal to 0. That's easy because it's a ratio, and the ratio is 0 only when the numerator is 0. So root of 4r squared minus x squared, or you can take, take this on the other side. So when it goes on the other side, it becomes 0. You're left with 4r squared minus x squared equal to 0, which means x squared is 4r squared. And when you take the root, x becomes 2r. I hope it's correct. Yeah, it's 2x squared. Sorry, I've dropped the 2 here. Yeah, 2x squared. So it is going to be 4r squared. So when you cut x squared is going to be 2r squared. So x is going to be root 2r. So you're getting the value of x as root 2r. If you can substitute in this equation or in from 1. Okay. From 1, you will get the y value also as 4r squared minus 4r squared. 4r squared minus 2r squared. So that is 2r squared, that is also root 2r. So you've got the x value as root 2r, you've got the y value also as root 2r. Now the thing is not over, we have to confirm that it's maximum. So let's check where we can confirm the maximum. I was just wondering if without rubbing, if I can manage somewhere, I think I'll take this place. Let's take this place and let's check this maximum there. So therefore, d squared a by dx squared at x equal to root 2r. Or root 2r, yeah, x equal to root 2r. Let's see how that works, because you have the numerator minus 4x, so that's going to be minus 4 root 2r, and then in the bracket we have got 4r squared. X squared we all know is x squared is 2r squared, so 2r squared, so this is going to be 2r squared, first term. Second term is plus x, which is root 2r, and in the bracket it is 4r squared minus 2 times, this will become 0, luckily for you, and in the denominator you have got 4r squared minus 2r squared, so that is 2r squared root 2r squared. So this is going to be 2r squared and root 2r, 2r squared, so root 2r, yes, root 2r. Okay, now this term is gone because this is becoming 0, and this is a negative term already. So overall it's going to be negative because there are two parts in which one part is fully 0 and this part is negative. The sign negative we can see there. So it's going to be the entire term is less than 0. So x equal to root 2r is a point of maxima. So let's conclude the way they ask us the question. They say that show that of all the rectangles square, yes, since x comma y equal to root 2r, therefore square has maximum area, because the side, both the sides are same, na? Square has maximum area. Now you don't have x and y different values, you have the same value, so therefore it means that there is a maximum which is happening at the square. So that's all about this, that's all about it. And from here on we are going to start a total new category of problems about maxima minima, so there where you get the core application. That's all for today. With more videos we can meet in the next sessions. So as usual, please popularize the channel, see that it gets famous with everybody, and keep spreading the word. Thank you.